name is Satish Kumar Sukumaran from group number 3. Here we'll be presenting on the discussion on tutorial 7, question number 3 with my team member Thurkesan. So question 3 states that a particle moves on a straight line with the velocity against time graph shown. I'll be explaining on A, B and D while Thurkesan will be explaining on C. So it is given that when t equals to 0 second, the displacement is negative 50 meter. So to be noted also that for this question it says the particle moves in a straight line, which you need to consider that it is in a rectilinear motion. So equation of the straight line, which is y equals to mx plus c, needed also. So interpreting this graph, so as y equals to v and x equals to t, we will be getting equation of v equals to mt plus c as our equation number 1. So for question A, we need to find acceleration when t equals to 7 seconds. So t equal to 7 seconds lies on the duration of 0 to 10 seconds. So when t equals to 0 second, v equals to negative 6. So by substituting all this into equation number 1 that we find earlier, which is v equals to mt, so substitute v equals to negative 6 and t equals to 0. So by doing this, you will getting c equals to negative 6, because when m multiply with 0, it will be disappear. So c, therefore it equals to negative 6. So when t equals to 10 seconds, which 10 seconds, so v equals to 10 meter per second. So substituting into equation 1, we'll be getting 10 equals to m multiplied with 10 negative 6 as for c that we found earlier. So 10m equals to 10 plus 6, end up with we're getting m equals to 1.6. So therefore the equation of straight line for duration 0 to 10 seconds will be v equals to 1.6 t minus 6. So we substitute the gradient m and also c equals to negative 6. So as for the question asked for acceleration, so we already have velocity. So velocity to acceleration, as for this formula, it needed to be differentiated. So as a equals to differential of v equals to, when we differentiate this equation, you will end up with 1.6. So for a, we will be getting acceleration equals to 1.6 meter per second square. So for b, we need to find the displacement when time equals to 10 seconds. So in this case, time of 10 seconds lies on the duration on 0 to 10 seconds and also 10 to 15 seconds. So I choose 0 to 10 seconds using v equals to 1.6 t minus 6. And also it is given that when t equals to 0, s equals to negative 50 meter. This into considered. So we need to find displacement. So we got the velocity. So for velocity to displacement, will be integrate. So integrate displacement equals to integrate velocity dt. So the limit of displacement will be until negative 50 to s. So negative 50 to s ds equals to 0 to t, 1.6 t minus 6 dt. So s minus in bracket negative 50 equals to, when integrate of 1.6 t, you will be getting 1.6 t square over 2, and integrate negative 6, you will be getting negative 6 t, and the limit will be 0 to t. Then negative will be positive, so s plus 50 equals to, when we fractionize, it will be 0.8 t square minus 6t to the limit of 0 to t. So s plus 50 equals to 0.8 t square. After we substitute t minus 0, we will be getting 0.8 t square minus 6t. So therefore, the equation will be s equals to 0.8 t square minus 6t minus 50. So we need to find displacement when t equals to 10 seconds. So substitute 10 seconds into this equation. You will be getting s equals to 0.8. Substitute with 10 square minus 6 bracket 10 minus 50. You will end up with displacement equals to negative 30 meter when t equals to 10 seconds. So as for d, we need to find the displacement when t equals to 12 seconds. So t equals to 12 seconds lies between 10 to 15 seconds as for the graph, you can see. So with this, for finding gradient using this formula, which is y2 minus y1 over x2 minus x1, we'll be getting m equals to v2 minus v1 over t2 minus t1 as for this graph. And we're getting 0 because while substituting v2 and v1 equals to 10, so 10 minus 10, you'll be getting 0, which you'll be getting the gradient equals to 0. When we substitute the gradient equals to 0 into the formula, v equals to mt plus c, so therefore c equals to 10. From the finding that we got from B, when t equals to 10 seconds, s, which is the displacement, equals to negative 30 meter. So that into considered. So this is also, we need to find displacement from the velocity that we found equals to 10. So it is also, we need to integrate. So integrate ds equals to integrate to v to dt. So the limit is for displacement will be negative 30 to s, and t will be from 10 to t. So negative 30 to s ds equals to integrate, then we'll be integrating limit 10 to t, which is 10 dt. So after integrate ds, we'll be getting s minus in bracket negative 30 equals to integrate 10 dt will be 10t to the limit of 10 to t. So negative will be positive. So s plus 30 equals to 10t minus 100. When we substitute the limit, we are getting this. So s equals to 10t minus 100 minus 30. So the equation we'll be getting for s equals to 10t minus 130. So the question asks for displacement when t equals to 12 seconds. So when t equals to 12 seconds, we substitute t equals to 12 in this equation. So you getting, when we substitute, it will be s equals to 10 t substitute into 12 minus 130, and you'll be getting s equals to 120 minus 130, left with displacement equals to negative 10 meter when t equals to 12 seconds. That's all from my part. So now I'll be handing over to Thurkeson to continue. Thank you.
Hi guys, my name is Turkesan. So today I will explain to you about how I do question 3 part C. A, B and D will be doing by Satish. So I will do C. So the question C says distance traveled for duration 0 to 25 seconds. So in order, if you want to find the distance, first you have to divide it by how many segments. So in this question we have 3 segments, which is 0 to 10 second, 10 to 15 second, 15 to 25 second. So if you look in the graph, you can see that there is 3 segments, 0 to 10, 10 to 15 and 50 to 25. So next what we have to do is, for the first segment, take the equation we got for velocity and displacement. So for 0 to 10 second, we get the velocity equation of v equal to 1.6 t minus 6, and the equation for the displacement is s equal to 0.8 t square minus 6t minus 50. This equation you can get from the part that Satish did one. So for the importance of this equation of velocity is, we want to find out if the particle changes direction or not. So if you didn't do this part, you will don't know when the particle changes direction, and you cannot find the accurate value of the distance travel for the duration from 0 to 25. So in order to avoid that, if you want an accurate distance travel, you need to do this methods to get the distance travel from duration 0 to 25 seconds. So take v equal to 1.6 t minus 6 and calculate what is t. So it's very easy to find t. You just have to take out the t and you will find it as 3.75 seconds. So this t equal to 3.75 seconds simply means that the particle changes direction. So if you want to know how long does it change, how long did the displacement changes direction, you have to take t equal to 3.75 second and substitute into the equation you got for the 0 to 10 second, which is s equal to 0.8 t square minus 6t minus 50. So if you substitute these 3.75 second into that displacement, you will get how long the distance is traveled from 0 to 10 seconds. So if you substitute it, you will get negative 61.25. So the displacement for the first segment is done, which is 0 to 10 seconds, is negative 61.25 meter. So the second segment is 10 to 15 seconds. So to 10 to 15 seconds, the equation we got is v equal to 10 ms negative 1. This simply means that the particle does not change direction. Okay, so this v equal to 10 ms tells you that the particle does not change direction. So the segment for number 2 is cleared. So for section 3, which is 15 to 25 second, so the first equation for velocity we got from this 15 to 25 second is v equal to negative t plus 25, and the equation for displacement is s equal to negative 0.5 t square plus 25 t minus 2 for 2.5. So if you want to okay, I'll give you simple why we use v and this equation. Okay, we take v, this equation, to find the time. We take this time to find the displacement. This time simply means that during when the particle changes direction. So this one means that when time is equal to 25 seconds, the particle changes direction. So that is what it simply means, t equal to 25 seconds, which means that when time is 25 seconds, the particle changes direction. I will explain to you in this part, draw the pair, it will be easier to you to understand. So from this equation, you take out the t, which you will get 25 seconds, then take that 25 seconds and substitute into the displacement where you got from this section. The equation from the displacement is s equal to negative 0.5 t square, and this equation you just substitute it inside and you will get 70 meter. So during this segment, the displacement is 70 meter. Okay, now we have to draw the path to find the distance traveled. Okay, first the highest value is 70 meter and the lowest value is negative 61.25. So you just put a center point of 0, highest value 70, lowest value is negative 61.25. You can see that the question says that when t equal to 0, so it is negative 50 meters. So when time is 0 second, the path starts here. So this is the original point, the starting point. Okay, so for 10 to 15 second, for 0 to 10 second, you can see that when time is 3.75 second, the displacement is negative 61.25. So it means that when it's traveling here from here, when it's 3.75 second, the particle changes direction. So once the t is go to 3.75 second, it simply changes the direction. So I draw it when it's going to 3.75 second, it changes direction. So it changes the direction. It changes direction. You can see from here, it changes the direction. It's going for left, then it's going right. So okay, now the second segment says that when t equal the particle does not change direction. So when v equal to n, the particle does not change direction. And the third segment says that the particle change direction when it's 25 seconds and it's 70 meters. So it says that when the car hits 70 meters, then only the particle changes direction. So once the particle changes direction at negative 61.25, until it reaches 70 meters, it doesn't change direction. So it changes direction here at 3.75 seconds. At negative 61.25, it changes direction. After that, it doesn't change direction until 70 meters. Okay, do you understand? So it doesn't change the direction until 70 meters. Then it changes direction here. So we only are doing until 0 to 25 seconds. We are only doing it until 0 to 25 seconds. So it changes direction when it's 25 seconds. So we doesn't need to calculate that. So the total distance traveled is from here to here is 11.25. Okay. If you take 61.25 minus 50, you will get 11.25. Then from here to here, it's, so you take 61.25, 0 to 61.25, which means from here to here, it's 61.25 meter. And from here to here, it's 70 meter. So you just take 70 plus 61.25 plus 11.25, you will get the total distance traveled, which is 142.5 meter. That's all. So I hope you understand what I explained to you. Thank you so much.